Okay, good morning students. Today we're going to solve question 10 from GATE CSE 2025 set 1. The question states that a shop has 4 distinct flavors of ice creams, right? There are 4 distinct flavors of ice creams. Let's denote those different flavors by these numbers 1, 2, 3, 4. It is going to keep the question systematic so that we can solve it more easily, right? One can purchase any number of scoops of any flavor, so there is no restriction on the number of flavors that you want to choose. Okay, the order in which the scoops are purchased is inconsequential. Okay, so when order is consequential, that is called permutation. When order is inconsequential, that is called combination, right? So the combination we are considering. If one can purchase 3 scoops of ice creams, right, in how many ways can one make that purchase, right? So 3 scoops of ice creams we have to purchase. So the number of slots, number of free spaces that we have are 3, and they have mentioned that the one can purchase any number of scoops of any flavor, right? So there is no restriction on the repetition of your flavors, right? All 3 of them could be filled with one only. All 3 of them could be filled with one, or they could be filled with distinct elements like 1, 2, 3, right? Or 2 same and the third different like 1, 1, 4. Right, and their order in which this is done is inconsequential. That is 1, 2, 3 is equivalent to 3, 2, 1, 3, 1, 2, and 1, 1, 4 is equivalent to 4, 1, 1 and 1, 4, 1. Right, so this is what they are trying to ask, right? So at first glance to students it is going to appear, how can I solve this question, man? Right, so one way that they try to solve is that they think that there are 4 flavors and there are 3 gaps over here that we have to fill. So why not just see how can we pick 3 elements from these 4, right? 3 elements from these 4. This is the reasoning that they do, and hence they apply that 4C3 must be the answer. Now 4C3 is basically equals to your 4. You can calculate it. It is going to give you 4 only, right? So 4C3 is going to give you your 4. Now the problem that the students are not able to understand in this kind of wrong analysis is that their repetition of elements are possible, right? So suppose that I am picking 3 elements from this, then I am fine, all distinct combinations you will get for this formula, but the combinations in which 2 or more elements are same are not going to be considered. Hence this is not the correct approach, because this is direct combination and not combination with repetition, right? For combination with repetition, there is a direct formula based basically a formula that we directly can use, but obviously I'm going to explain to you how that formula actually comes about, so that you can remember it more firmly in your mind and it may come handy to you in the examination. But before applying that formula, let's just solve it analytically, right? We must have that much confidence in our own analytical power that we can solve it analytically. Obviously there are some questions which this cannot be done for, and you have to use standard formula there, but sometimes, like for example in this one, if you put a small amount of time into it, it can be directly solved by direct analysis. I'm going to try to explain to you how I did it so that you can understand it. Let's go on and do that first. Okay, so pure direct analysis, right? So first, in your mind, consider you're given these 3 slots. What kind of combinations can there be? I mean, can there be a different categories that you can consider? I have actually already told you by this much part of the video. I've already told you that obviously there are distinct, and then there are 2 same, and then there are 3 same. That is what you must consider, right? That is the distinction of possibilities that exist in this particular arrangement. Sometimes it does not click in the mind, but obviously the whole point of education is to basically have you able to distinguish and discern this kind of possibilities, right? So there would be the possibility that all 3 elements are distinct, that no element is same. When that is the case, then directly this formula can be used. This formula directly can be used, and that is how we're going to get 4 over here, right? 4 over here if there were to be no repetition. Okay, this is the element of this question that is corresponds to the combination without repetition. Now because of combination with repetition, these 2 more possibilities arise. Those are that 2 of the slots were to be filled with 1 and the rest was to be distinct than 1. right? Because only 2 same is the possibility that we're considering over here, right? And you may say that, okay, but why did you only pick the last spot to have these distinct elements? Why not in the middle? As I've already explained, the order does not matter. The order is inconsequential. If the order would have mattered, we would have been considering permutations, but it is not permutations that we're considering because the order does not matter. So 114 is equals to 411. It is combinations that we are trying to pick up, right? So if I were to take the middle point, it is similar to this one. There is no distinction over there, so we don't need to consider that, right? With that 1 1 over here, we can have 3 elements over here. With 2 2 over here, we can have 3 elements, right? So for 4 of these categories, we can have 3 elements. So 4 cross 3 is going to give you 12, right? So for 2 combinations, there are going to be 12 combinations that are possible, right? For all combinations, as is clearly visible, there are 4 possibilities. Let's add them together. It is going to give you 4 plus 12 plus 4. 4 plus 4 is 8. 8 plus 12 is equals to 20. That is your 20. Now come back to this. Which of the option is 20? Well, you can see that the B option is actually 20, and that is the correct answer. Even you can match this with your answer key that was provided for this particular paper. I have already matched it, and the answer is indeed question B only, right? Now let's go on and try to understand it from the approach that is generally taught in this manner. But I am going to, because now we have done it from an analytical point of view, we will have more confidence when we are trying to understand it. I will even try to explain to you that concept of combination with repetition from the fundamental concept, so that you can have a better understanding of the whole thing, right? If you want to add some constructive criticisms to how I am explaining, or any plus points that I may miss out, please do add them in the comment section. If they are very good, I will also pin them. Okay guys, so that now we have understood from pure analysis how to solve this question. So I would like to show you what kind of possibilities can exist with these constraints being present, right? 4 kind of flavors, and we can take 3 scoops of any kind, right? With these constraints, what all possibilities we need to consider if we not know this analytical method that I have taught you, right? So I've taught you, but somebody taught me also, right? So humans have invented this analysis method, and without this method, what kind of possibilities are there that you must systematically go through to get to the same answer, that is 20, right? How? Let me show you the data, right? So these are actually the 20 combinations for the 4 flavors that exist over there, right? So let these things separated by comma and written inside of these 2 lines, right? So they represent your flavors, right? First flavor, second flavor, type of flavor, third type of flavor, how many scoops were present of that, and how many scoops of fourth were present, right? So in this data point, there were only scoops of the fourth flavor. In this data point, there were 1 scoop from the third flavor and 2 scoops from the fourth flavor. And this data point, 2 scoops from the third flavor and 1 scoop from the fourth flavor, and so on and so forth, right? And these are the 20 possibilities that you would have to consider to get the 20 answer, right? So either you can be very creative, so you can directly write all these things, but normally so we are not Einstein, no, so we cannot directly write it, and obviously even Einstein would have to consider all permutations, right? So from bare arrangements, right, every one of these can be from 0 to 3, right? And we can produce all that, and then from that cherry pick all those possibilities that add up to 3, right? That is how we would have to do, something that you would have to do in order to get a comprehensive list, that you must be very sure, right? If you were to try to find lists like in this manner, then you would come till 5 or 7 or possibly 10, and then you would say that yes, all possibilities are already considered. How can you know that you have exhausted the list, that all possibilities you have listed down? For that, you must go through like this, that for every kind of flavor, you take all possibilities from 0 to 3, all possibilities from 0 to 3, and like that. You would have to consider all of them and then print all of them, and then from that cherry pick. Let me show that. Like this, you would have to do. You would have to print all of the possibilities, and from that you would have to say, okay, so in this 0 plus 0 plus 0 plus 3 is going to give you 3, right? So at 3, the sum is coming out to be 3. So very good. That is very good. So that is a possibility that we can take as a answer adding
possibility. So that is one of them, this is one of them, this is one of them, this is one of them. I've basically written all of the possibilities on top of them, right? So that you can have better understanding. So see, all these possibilities you would have to consider in the examination, or even in your daily practice. You would never think of solving it in this manner, right? But I am only showing you this so that you develop a appreciation to the analytical methods that we humans have developed. One of the most significant portion of learning any technical stuff is developing the appreciation for that topic. Because once you develop the appreciation for that topic, your brain keeps that information in handy so that you can actually apply it in future, right? So that is what I'm trying to develop in you by giving you all this information. I also did not write all of this by my own hand. I used a computer program to print all this. I have provided the code for printing, that you can also go through this if you want, and then you can understand that. But obviously it is purely so that if you want to dive deep into this, you may have all the information, right? For that I've given you this. Now once I have told you all this, now let's try to attack the actual formula that you must have heard many times, that is used in this case, that is repetition, combination with repetition, the formula that is used, right? I'm going to give you a very good understanding of that. Let's come over here, right? So this is the formula. More concretely, this is the formula, right? In this, what is N, what is R? N is the number of ice cream flavors, right? Or ice cream flavors is particular to this question. In general, N represents the total number of possibilities of input that can exist, and R represents the total number of slots or the spaces that you would have to fill. In this case, the spaces that you have to fill are the scoops of ice creams that are taken out of that, right, and presented to whoever. Okay, so that is what these N and R are, and with that this formula exists, right? Before coming, you will basically understand the formula by itself only once I explain to you how exactly it is coming. So let's represent. So till now, in all the concrete examples that I show over here, you would have noticed that the sum of all possible, all the type of flavors that are being presented and their numbers that they are contributing to the slots or to the possibilities, to the R that they are contributing to, right? In this 3 of 4th kind of flavor, right? In this 2 of 4th kind of flavor, 1 of 3rd kind of flavor, right? So their sum of all these is always equals to your 3, right? The number of slots, the number of possibilities, the number of scoops that you are taking out, right? So this is the exact same formula that we have taken over there, right? This is the exact same formula. And we are basically considering over there the way in which we can fill these numbers so that addition can come out to 3, right? This is what we were doing over there, and this is, we have written it in this manner. We have just written it in a systematic manner, as an equation, right? So now from this equation, as you can see, the number of flavors, that is 1, 2, 3, 4, is equals to N, right? So this will correspond to N, the total number of possibilities. And the plus signs that are present in between them is 1 less than N, because for every let's consider the first element, for the first element there is 1 plus sign over here. For the second element there is a plus sign over here. For third element like so, but for the last element there is no plus sign over here, right? So the plus signs must be 1 less than N. This is what I have written over here, that the plus signs would be 1 less than N. And R, this 3 is what? This 3 is basically addition of 1 plus 1 plus 1. So this 3, if broken down into that 1 and then written over here like this can be written as just an intermediate kind of information that we're generating. The fun part about this is this intermediate information that we can generate very easily, very directly. You can say that yes, we're just representing it in a different manner. The trick of this technique is that people realize that the number of ways this representation can be arranged in and of itself, right? So this representation can be written like this, like this, like this, like this, right? So these representations can be written like this, right? So number of ways these representations can exist, that will equal your total number of combinations with repetition. This is the claim of this whole formula. This is the trick that the people found out, right? This is it is so important that I wrote it over here also. The claim is that the total number of distinct permutations of this intermediate representation is equal to the total number of combinations with repetitions that are possible with this kind of question, right? So you would say, how is that the case? Because I don't understand. You will understand once I go give you some examples, right? We as humans can only comprehend patterns, right? So if I were to give you very good examples and show you those patterns, and at least 3 examples are required for to make a pattern, right? If I were to explain you 3 and I will explain you 4 just for feeling sake, okay, then you will have a very good understanding and you will say, okay sir, now I understand why this is happening this way. Okay, so let's take a particular case. Let's take the first case over here, right? The plus sign, there are 3 plus signs, right? So let's see and these plus signs distribute the whole formula. These plus signs distribute the formula in this representation into four kinds of 1, 2, 3 and 4 places, right? Let's correspond these 4 places to your number of flavors they contribute, number of scoops that they contribute, right? Because over here there is there is a total of only a single one over here. That means that of type flavor 1 there is only 1 scoop, and there is 1 scoop of type 2, and then because there is no number over here, so there is no scoop of type 3, and there is 1 over here, so there is 1 scoop of type 4. This is what this representation gives us, right? And what does this corresponds to? What does this corresponds to? This corresponds to your this possibility. Let me right? So this is 1 1 0 1, right? So 1 1 0 1, and that is this one. This thing corresponds to this thing, 1 1 0 1, right? And then let's go and look for the second possibility. If you were to take this, right? So for this, there are 4 distinct positions that these plus signs distribute the whole thing into. One is this, one is this, one is this, and one is this. For this one, it goes till here, like over here. So there are 2 ones over here. So the number of scoops of type flavor 1 is 2. For over here, for these 2, there are no numbers present. So for this and this, there are going to be 0 scoops present, and for the last one there is going to be 1 scoop present, right? Let's go for another one. So over here, from this you get that this one, there is 1 scoop of this, 1 scoop of this because of this, and 1 scoop of this, and no scoops of this one. That is what this representation gives you. And from this one, last one, you get 2 scoops of flavor 1, 0 scoop of flavor 2, 1 scoop of flavor 3, and 0 scoop of flavor 4, right? This is what you get. I've given you 4 of them. Now at least I would like to say to you that, guy, you must have noticed something. You must have noticed that every permutation gives you a valid combination of the possibility of scoop distribution that is done for these 4 kind of flavors, right? And as such, if there is not going to be any possibility which is going to be rejected by this, because these 3 pluses does in fact divide the whole representation, the ones, into 4 different categories, and all permutations of this representation are taken, that is by inherently equal to the solution to this question, that is combinations that can exist with repetition. If you did not follow this along, rewind the video, watch it again. This is one of the best explanations I think there exist on this topic, right? Once you understand that, yes, okay, this claim is very clear to you. Once this claim is very clear to you, this formula would become clear to you directly. Why would that be? You would say that okay, I understand this combinations of this kind of representation, this intermediate representation is going to be equal to that, but how would you find the combinations? very easy. You know the number of spaces that are present over here. The number of spaces contributed is basically equal to 1 2 3 4 5 6, right? So six number of spaces exist over here, right? From these 6 spaces, the number of these ones, right, these ones, if you were to find the from these 6 spaces, if you were to find the total number of ways in which you can pick r number of, that is number of ones that are present, this is r. So the r number of spaces, if you can pick, once those r number of spaces are picked, the plus signs can directly then fit into the remaining spaces, right? There is no restriction over there. There is no restriction over there. So once you pick the r spaces that can exist over there, right, that is basically equal to your answer. And what is the formula to pick them? What is the formula to pick them? Man, that is C, that the total 6C, and then there is going to be R over here. And how is this 6 contributing, 6 coming around? This part is your R, this part is your n minus 1. So just add them, that is equals to your total number of spaces. That is what we are taking as 6. So that is going to give us this thing, n plus r, n minus 1 is taken at the right end over here, but it is basically n minus 1 plus r, right, whole C. And that is the formula that actually is used in these contexts, right? You must have seen this, but I do think that I have explained to you this concept so that you have better understanding on this, right? So obviously this you will think that you have understood it very well, so you will forget, so you will not forget, and you directly apply in the examination, you will never revise. No sir, you must revise every few days so that this concept is very clear. Practice is the key when it comes to aptitude, man. There is no other. Again, aptitude in any technical knowledge, if you cannot practice it, then you cannot compete, right? Because and then many people have this insecurity that the technical domains are very big, so you cannot practice everything all the time. You will forget a lot of things. Yes, that is true. Technical domain is indeed a very very large thing, but the aim over here is not to become an Einstein in this domain, right? Einsteins are very rare. They have a very good memory and all analytical power and everything. But because technical domain, the mastery of selected portion is more valuable. The quality is more valuable than the quantity, right? So pick only few topics, but master them, practice on them, right? Distinguish what all things you have to master and practice on them thoroughly, right? Even in a job, if you were to do, you take up a field, take up a role, and then master on that, right? You don't pick up everything. No guy still develops every app from start till end, right? And now I explained to you a lot of information that I should not be explaining to you. This is a simple question and this is a simple answer, and I've explained to you the whole thing. Hope you like the video, hope you learned something, and have a nice day. If you like the video, like and subscribe, and have a very good day.